Hello CIS40A. In this video, I'm going to cover the lab as my Zoom session did not have sound for the first half. So I just want to make sure that you're able to get a little bit more understanding on what you need to do for the lab. So if you're working from home, you will need to use your wireless router and do your best in having comparable configuration obtained. If you were in class, then you can use the TP-Link AC router 750. So as I am connecting to the router, I would use the wireless adapter, or if you have an Ethernet adapter installed on your computer, you can use an Ethernet cable and you would connect to it, not to the WAN port, but to the LAN port. It will be any of the port that's not labeling WAN, because WAN is gonna be for the connection to the internet service provider. So you would start with opening up settings, and to connect to it wirelessly, we would go with network and internet, and you would click Wi-Fi and then show available network, and this is going to appear on the right. So you would find the TP-Link. You can either use the 2.4 gigahertz or the 5 gigahertz. So on yours, it will show your router information there, or the router SSID. And I want to make sure that my Wi-Fi is on if I'm using Wi-Fi, and then I would locate the network. If I'm using the wired, the Ethernet cable, I simply plug it to the back of the router and to my computer. And once you do that, it should take a second, and it's going to show you the connection in network and internet settings. Okay. So in our lab today, we are going to look at the configuration on the TP-Link router. And so once I have wirelessly connected to the router, I'm using the SSID and the PIN number, which is usually printed on the sticker of the router. Then we would then open up a browser, and on the browser we would then put in the IP address of the router, which is 192.168.0.1. Now, if your router uses a different IP address, it's because out of the manufacturer, you would have a different address ingrained onto the router to the start, or program onto the router on the start. So you would refer to the manual on the router for that. So the first thing on a brand new router, it's going to ask me to configure the password. And in our assignment, we want to use P @ symbol AS $WORD. So we can go ahead and do that there. Now at home, you want to use a unique password. So we want to be able to configure our router to use the proper unique password. And if you don't remember, you would then need to reset, which default back to the manufacturer setting. And on your router, there would be a reset button, or sometime you would hold down the Wi-Fi button for a few seconds, and it will be able to configure that. And then we want to confirm our password again. And we're going to go ahead and click start. So on the TP-Link, it's going to take you to the graphical user interface for configuration after you had set the password for the first time, and you would use the password to be able to administer it. So the first one is going to be our status, and here what you see is it's going to give you a help panel on the right. So if you're not sure what everything is, you would be able to look there. So on this status page, you would see the hardware version information, the firmware, and also we would have the MAC address for the LAN and the IP address for the LAN. So your router uses this MAC address, and this is the IP address for it. And the subnet mask is here. So when you're looking at this IP version 4, we would look at the first octet, which is 192. And that octet represents the network value. So now if the network value is between 1 to 126, that will be a class A address. If the network value is between 128 to 191, that will be class B. And if the network value, the first octet, if that value is 192 to 254, that will be class C. So as we can see that our router here is a class C address, and it uses the default subnet mask, which is 255, 255, 255.0. This, think of subnet mask as like a zip code. So inside the city, we would have many zip codes, and each of the zip code can represent a subnetwork. So 255 indicated that this is a network. So it's going to refer to the first 3 octet of your, by default, it's going to the system going to refer to the first 3 octet to identify the network value, and the host number, which is unique to each system, that's going to be this back number here, 1. So on this router, we know that it is a dual band by looking at the frequency. So it has wireless 2.4 gigahertz and 5 gigahertz. So it would say that this is a router mode. And on the 2.4 gigahertz, I would have 11 BGN mix. So that means that it's 802.11b, classified B, G, and N for the standard. So this router has the capability to work with those particular standards. Now, if you have a laptop that is 802.11b, it would then be able to work with this router. But if you have a router that is 802.11b and your laptop is 802.11ac, which is a newer laptop, the laptop with the newer standard will not be able to connect to the older standard. So the router is not going to be able to see your laptop as it will not accommodate the newer standard. So here you would see the information that you need for the actual classification. So on your lab, it tells you to go through quick setup, and then we are going to go ahead and click wireless router and then close the quick start setup. So at the home, you would go through the quick start setup, connect the internet port, which is the WAN, to the internet service provider, and it would give you the actual network connection, the internet connection. So on the status, we want to note down our IP address, which I had previously explained, the subnet mask, the MAC address, which is the physical address. And for the MAC address, you would see that it is represented in a group of hexadecimal value where there are 2, 4, 6, 8, 10, 12 digits. And so on the MAC address, that will be the physical address to the router. So then on the lab, it tells you to record the information. Now, how can I find a channel for each of the band? I can go to each area here, and then it will tell you the channel, which is auto, and the channel here. And as you notice on the channel for the router in 2.4, that will be different than the channel on the 5G, which is 149. So on the 5 gigahertz, you do have different channels and more channel compared to 2.4 gigahertz. So we would then look at the information that we receive on when, since we're not plugging it in, it would be that, and then the Ethernet, I don't have it plugged in. So you don't have to use the Ethernet cable to configure your router. You can connect to it wirelessly. Then on the next one, we want to look at the quick setup. So we can go ahead and click exit there. And so here is where we would have the status information from earlier. On the operation mode on this router, it has 3 features. It can be a wireless router, or it can be an access point, or it could be a range extender. So access point cannot be a wireless router, but wireless router can be an access point. So access point cannot be a wireless router, but wireless router can be an access point. So then once I go to the next part, I will look at the network. And here what you would see is that it is obtaining IP address dynamically. And so if you now on the WAN side, since we don't have it connected, it will not show anything there. So I'm going to go ahead and click on the LAN. Here we would see that this is our router IP and its subnet mask. And then here's the MAC address. So we are going to click save. And then for the IPTV, we would see that it's enabled. So if you want to disable it, you can simply check this. But on the right hand side, it tells you what Igp snooping is. It's a way that we can prevent hosts on a local network from receiving traffic for multicast group. So if you wanted to stop it from receiving the multicast, multicast just means that it's going to send from one system to many. So you can disable or enable. So now on the IGMP proxy, we can select it to enable the IGMP proxy. And so the version that we're using is version 3. And if you enable IPTV, you can select this option, and then it will allow you to select the mode for the IPTV. So if you don't, then you can uncheck this. We can go ahead and click save. So for the next part in your lab, you would then need to take a look at the LAN and review the IPTV settings, which options are on the selected default path. So we can see that for the options for the options that we wanted to look at that will be selected by default, we would see that we have Igp snooping and IGMP proxy. And snooping just is designed to prevent hosts from the local network from receiving the traffic. And so if you want to enable that, you can. Or if you want to disable, you just uncheck that box. So here, I would see that I can see that in the IPTV option as well. Okay. And so make sure that you write down the information for IGMP snooping and record the default setting. Then we are going to go ahead and click Mac clone. So on here, if we click Mac clone, it's going to take the PC address and it's going to put it into the WAN address. So if you click clone Mac, you're going to see that it's going to duplicate the PC, and then we can go ahead and click save there. So if you wanted to clone the Mac, you will be able to do that. Now, if you wanted to change it back, you can reset the router to using the reset button. So now in the lab, it's then going to ask you to take a screen capture of your clone Mac. Now, if you don't have that on your wireless router at home, that's okay. You just go ahead and take the configuration of your MAC address information. I'm fine with that. For number 15, we are going to go ahead and enable a new MAC, and we are going to allow it, and then we're going to take a screen capture. So we are going to go ahead and click You'll go ahead and click save there. And on the, if we continue to go to the dual band section, you're going to see the dual band. There's the wireless 2.4 gigahertz. It's enabled as wireless. It's mixed. You saw this earlier in the summary page. And the channel settings are here. So on the 2.4, you have 1 through 11. And then the width of that is going to be 20 megahertz or 40 megahertz. If you enable SSID broadcasting, that means it's going to advertise the SSID. You can have this option selected, but if you don't want it to advertise as SSID, we can uncheck this option. So then we are going to go to the WPS. This allow you to use Wi-Fi protected setup, which it is enabled, and you can disable it if you like, but in order to set it up, you can use the PIN, which we originally put in, and then we created the password. So if you wanted to restore the PIN that will be there or generate a new PIN, you can click that button. We can go ahead and click the add device, and we can say how we wanted to add that device, if we wanted to input a special PIN for that device, or we can use the press WPS button. So likely in the business environment, you're going to see that they would issue the PIN in order to connect to that wireless router, and so on. So we're going to go ahead and click that. In the wireless security, we would see that it would use WPA2, which is the best security encryption or the wireless encryption at this point in time. And we wanted to have it WPA2, not WPA, and AES is the encryption type. You want to stay away from TKIP as it's not as secure, but we want to select AES. The wireless password is going to be the same PIN that what we see. Then for the rest of the settings, that will be your WPA, WPA2 enterprise. So for the enterprise version, or the configuration of this is going to allow you to also add radius server. So as you don't need the radius server for home use, we would then select the first option. Then on the third option, which is WEP, which is the weakest, and we don't want to use this because it's going to use the pre-share key. So we want to select the other option instead. Then after the security, we would go to MAC filter. And I suggest that when you MAC filter, you want to allow the system. So that way everybody else that's not on this list is going to be rejected when the devices that are not on the list trying to add to the wireless network. So we can click add new, and then we can input a MAC address. So that way we would be able to add that particular device, and you can add in the description for that device. And so once you have that saved, so let's say what we would do 2D E4512813A. That's it. And then we can click save. Oh, I need to use a description, so I'm going to say PC. So as you add the address, what you would have is it's going to list under here, and we wanted to be able to allow that. So for this step, what you would do is you would take your another MAC address. It could be from another PC or your mobile device, and you would be able to add that MAC address. So make sure as we go through this, we list the type of encryption. We said that we're using AES, and the version that's used is going to be WPA2. Then we are going to add the MAC address. Once you add the MAC address, you're going to take a screen capture. We are going to select the allow option. So you want to enable that added address to be added to the network. So after you add it, you can click allow and take a screen capture. So for the next step, what you're going to do is you are going to go to the wireless statistic tab, and you should see how many systems that will be connected. So if I go into the wireless statistic tab, I might see none right now because I don't have a system connected. But if you do add a system, you would see the system listed here, its ID, MAC address, and its status, and the number of packets that it's receiving. So if you have many systems, it's also listed there. Some wireless router actually create a little map on this particular tab to show you how the system are connected within your network. Now on the 5G, you are going to have the same group of settings. Notice that on the 5G, you do have different channel width, 20, 40, and 80. And then also the channel numbers are going to be different. So in the 2.4 gigahertz, it was 1 through 11, where on the 5 gigahertz, it's going to go 36, 40, 44. So there will be an increment of 4 for each of the channel, and it's going to go from 36 to 161. Then we are going to, you can also add a system and deny that system from connection. And ideally, and when that happens, it should take effect right away, where if the system is already on the network and you add it to the deny list, it would automatically remove that system from, or disallow that system from accessing the wireless network. Then when you click on the 5G, you would be able to find its mode. So here, when I click on the 5G, I would see that it's also 802.11a, N, and on this one, we don't have the B and the G, but it has the A and the C mix. So we have the AC, which is compatible with, it has backward compatibility with N and the A. Whereas on the 2.4 gigahertz, you see that it would be the B, the G, and the AC. So on the different band, you would see that there are different standards that would be backward compatible, and that would be using a certain frequency like 5 gigahertz or 2.4 gigahertz. Then in the next part for the lab, we are going to click on the guest network. And here we simply click on the next tab. Guest network is default disabled. You can enable the guest network, and you can put a schedule on it for the access time. And guest network can be used temporarily, and then we would disable it to better protect our network. So on the Wi-Fi side, if we enable this, we can allow guests to access it. But if you don't have guests and in general you have internal devices, we would select the toggle for disable. And we can also isolate it by using the enable options. And we can also control the bandwidth on it. Okay, so on this router, you're able to do that. To schedule the limited time for the guest network access, you would be able to select and you can select timeout where you would set the time on how your guests will be accessing. So if you have visitors or you temporarily wanted to provide a guest network for public use, we would then be able to set it up with the schedule. Then on the question 20, make sure that you take a look at the guest network either on your wireless router or on the router that you have used in class and be able to include the answer for that. Then the next part is going to go over DHCP, and Dynamic Host Control Protocol is going to be used to provide IP addresses within your network. So on the wireless network at home, or on this router here, you can see that it also holds the role, which is DHCP, and its job is also to give out IP address. And by default, the setting for this is going to be the range from 100 to 199. That means that all the connected systems, could be smartphone, PC, or laptop, etc., they all will obtain addresses between 100 and 199. The router itself is 192.168.0.1. So .2 through 99 before the 100 here are not being used. The reason why that we want to keep those available, we can use them as static IP for dedicated devices such as servers or printers and so on. But if you just hook up your wireless printer and you want your wireless printer to obtain IP address from the wireless router, it would then obtain one of the IPs in this range, which is 100 to 199. So here we can specify the range, so you can change this up. So if I wanted to make this 200 to 250, I can do so. But in the lab, it simply asks you to take a look at the range that is provided by default from the manufacturer, and you can always change up the range as you need. The lease time for this is 120 minutes, which is a default value. You can lengthen this lease. That means that it's going to be able to give out that address for a longer period of use by changing this value. The default gateway is going to be itself. And if you have a domain, then you can specify the default domain, the DNS server IP, and the secondary DNS. So then at this point, we would then be recording your DHCP range, the default gateway IP address. And then we would go into looking at the DHCP client. So we would switch to the DHCP client list. So here I would have one, and that would be the computer that is connected to the router. So it would be 101 there. And the lease time is 1 hour and 30 minutes. So the client name is going to be unknown. So if the client is connected, it's then going to be recording it there. So you can frequently refresh it to see if there are any other device that will be then connected. So now if you click on the address reservation, you can display the static IP address that's assigned by the DHCP server. So then you would be able to add the MAC address, the IP address, and it would update the status for that particular system. So this address reservation is mainly used for devices that are reserved, devices that are dedicated in the network, and so on. So we can reserve something like 10 to 20. So that means 192.168.0.10 to 192.168.0.20. And we can also forward. So here is where you would do port forwarding. and that will allow you to add the device, the service port, the IP address, internal port if you have an internal port, the protocol, and the status. So when you click add new, it's going to ask you to fill out all of these forms starting with the service port. So in your lab, it had asked you to add a new device for port forward. So we are going to add port 53, which is DNS. And we are going to add the IP address 192.168.0.2. And we are going to leave the internal port empty. We can select TCP or UDP for the protocol. And then we are going to select DNS for the common service option and click save. So after you do that, what will happen is we are going to be able to link that system to the DNS service. And so once it's enabled here, we are going to go ahead and put DNS, and it's going to give us also the same port, and then we can click save. So then it's going to list the virtual server that we'll be using port 53 or DNS, which is the system with the IP address 192.168.0.2. Then we can continue to port triggering. And on the right hand side, it talks about port triggering. So some applications require multiple connections for games and purposes. So like video conferencing, internet, telephone. So we can use port trigger, and we can add the device that require port trigger, just like how you add the device that's needed for virtual server or port forward, to be able to utilize the port triggering capability on this particular router. So the rules would specify the port for outgoing traffic, and the outgoing connection using that port will trigger that rule. So the port that's associated with that rule would then be triggered when, and it's going to utilize the rule when it communicates. So here what you have is you can specify the port that triggers. So for example, if I wanted to put 20, and then, or I can just simply specify, right, the type. So let's say if I wanted to do BattleNet, right, it would then put in the port for the BattleNet there. So in the lab, it would specify the step for you on what you need to do. So here it would say we would select BattleNet, and then it would show the type of open port. And in this case, we would see that the open port is 6112 as we selected battle.net. And then we can specify the type of trigger protocol, TCP or UDP. So once you have that, and then you would record the open port information. Then we are going to click on the Dmz tab. Now Dmz is commonly found in enterprise network, where we would use one system or one IP address as public, and that's going to be the public front for us, where we can use it for things like internet gaming, video conferencing for home use, etc. But so the router is gonna forward the packets to that use that service to that particular IP address. So we would use a static IP, and we can set that up as a DMZ. And so in the DMZ, this address would then be publicly exposed, whereas you don't want to expose many addresses. You would want to use one, and you wanted to funnel all your gaming, your video conferencing through that particular one IP address as it is exposed publicly. So here is where you would set up the DMZ. And then on the next tab, which is your universal plug and play. And this allows you to connect devices that uses the universal plug and play, that has the universal plug and play feature. And the device can be automatically be discovered on the actual wireless router. Now, is that going to be secure? Not necessarily. So recommended that we disable the universal plug and play status instead of enable to use it. But if you need to use it, you can enable, and then you can add it would then be discovering the actual devices, and it would add it to the list here. So for the advanced security, so for the next part, we are going to go into the security tab, and we're going to look at the virtual private network and the application layer gateway. So right now, then we're going to go to security, and we are going to look at the VPN. So there will be PPTP pass-through, L2TP pass-through, and IPsec. So if you want the type of VPN traffic that's going to be routed from your router and to your router, then you can specify, you can enable those. So if you have people that are using virtual private network from home, then you want to make sure that this is going to be supported, so you can specify the type of VPN that you want to use there. And for the AOG, you would have for file transfer, for SIP, for other type of protocol. And if you wanted to know the protocol information here, it talks about file transfer clients and net meeting for Microsoft and so on. So once you have configured that, you can click save. Now under the basic security, and we can go into advanced security, in which we can specify the control for denial of service protection. So if I enable this, I can include how it would look at the traffic, and any time that it suspect that if the traffic is a form of flood or attack, then it would then block that particular traffic from coming in. So I can prevent ICMP flood, which is a ping flood, or I can prevent UDP flood, and I can prevent TCP SYN flood. So often that you would see denial of service using these protocols. This is ping of death or Smurf attack, or also called replay. And then your UDP, that will be just sending a lot of UDP traffic through to get your system to halt. And then TCP SYN flood attack is there. So you can see this on on the actual option for advanced security. And then we can also look at the block DOS host list, and it would identify the system. Now, if you want to forbid ping packet on a LAN port, you can select this option as well. Then we have parental control, access control, advanced routing. You can set up a static table, and also it can create a system routing table. So we would see that, the network that it's in is this, and it would specify the type of routers that's nearby and so on. And then you have bandwidth control and IP MAC binding. So as you see, once you had set up your attack settings or attack prevention setting, we can go into advanced routing, and we can click add a new button, and we would be able to put in the IP address that we want. So here what we can do is we are going to go ahead and click on advanced routing. We're going to go ahead and click new. We can put in 10.0.0.1 for example, and the subnet mask is going to be 255.0.0.0. That's a default class A subnet mask. And then the gateway, so let's say that we can say this is going to be R1 for the router 1, and the interface, we wanted to say that it's going to be LAN and wireless LAN, and we are going to enable it, and we can save it. So we can specify the address, and we would then be able to save it to your router, where it would then look for that other router to be able to establish the route. We can also specify other IP addresses instead of that one. So here what you would have is once you set that, you would take a screenshot or a screen capture. And then we are going to go into the System Tool tab, and then we're going to specify the time. And then we are going to look at the system log. So coming here to the Tool tab, we would then be able to set up the time zone. And we wanted to use Pacific Time Tijuana. And then we can put in the date for today's date. And that will be, the month is 09 and 03 for the day. And then the hour, we can put in the time and so on. So once we do that, it's going to click save. If you wanted to use the network time protocol to sync, we would then be able to use that from the .org and the North America pool. Or we can get it from our system where it's going to plug in the time there. Okay. Now there are additional options with, firmware upgrade. You want to do that occasionally, and then also backup and restore, so you can back up your settings, and then we can also reboot. But we're going to look at the system log. So here it shows me the DHCP, how it offers to the device. And then what we're going to do is we are going to also look at how it would be saving the log. And we wanted to make sure that we save this log, and we can save that remotely. So here what it's going to show me is it's going to send it to my system, and it's going to give me a log.txt file. And then if you want to change your log setting, you can click log setting, and we wanted to make it remotely, and we can point to the system that it will be saving, and we can specify the port and the user information. So, or we can also put in, we want to save only critical, and so on. So you can change this setting, but I highly recommend that your log can be saved locally and remotely, so you can access that log in case that system is damaged. So now on the statistics side, if it has system connection, it's going to give you the information and also the protocol that will be relevant to that particular system, the packets, and so on. So it does give you statistic information, almost like a network monitoring tool there. So you would be able to see once the systems are connected. So this concludes my video for the lab. Once you complete the lab, make sure that you provide the screenshot, the answer to the questions, and upload that on Canvas. And thank you for watching my video. I'll see you in the next one.